welcome guys. Well, so in this video, we are trying to prove the Rodrigues formula for Legendre polynomial. So let's quickly see what's going on, right? So the Rodrigues formula looks like this, right? So Pn of x. So this is our starting point, right? So in the beginning, in our previous video, one can already show this. Okay, so maybe I should. Okay, and so next thing is that one can just easily see that if you can just prepare all of it and by replace preserve these terms. Sorry, so it's a minus r term, minus 1 factorial terms, and the remaining is this, right? 2n 2r factorial x minus 2r. Okay, so these terms basically can be written as dx d divided by dx to the x2n minus 2r. Right, and the reason is that it will produce this coefficient. Okay, and this is constant, right? So basically one can just pull out this happy dx dn and written as this. Minus 1r n factorial r factorial n minus r factorial and x2n minus 2r. Okay, and so now basically we are done, right? So the final is that one just need to check this is x squared minus 1 to n. And the reason is that you can just use your lovely binomial expansion, so you get the n divided by r, right? X squared to the r minus 1 n minus 2r, right? And then maybe we choose this to be n minus 2 n minus r, and this is like r, right? So we have this, and then we have this term, right? So this term matches, and this term is n factorial divided by r factorial n minus r factorial, and then we can only choose r to go to the this floor n divided by 2. Okay, so combine all of it, we get a very beautiful relationship of this, not relationship, relation with the Legendre polynomial. Okay, so this is our Rodrigues formula. Okay, so let's go back and see how we derive this. So let's quickly remind you guys. And actually, I may need to, so I don't want to prepare another video to prove this. Okay, so I will just quickly prove it. Okay, so let's starting from our lovely definition. So in this in all video, I starting from the Legendre polynomial as generating function as this 1 minus 2xt plus t squared and the square roots. Okay, and it's very easy that you can write down as this, as a half, right? And then we use the binomial expansion for the fraction terms. So we'll get this 2 to the 2n n factorial square 2xt minus t squared to the power n. Okay, and then we keep using again. That's maybe slow a little bit. Okay. Okay, and then we can keep doing, right? So we can using again, right? So we get the n factorial 2n factorial 2 to the 2n n factorial square, and then we can use another again, right? So we get the k equals to 1 minus k n factorial k factorial n minus 1 k factorial, and then this 2x n minus k t to the k. And okay, so right, so usually it's basically starting point is 2xt by n, right? But there's an n, right? So I can pull out 1 t to n here, right? So we get this. Okay, sorry for the not good writing. Okay, and we can combine it to be from 0 to infinity k from 0, right? So now we start from k from 0 to n, right? But the point is that we can arrange it as we just change k to 2k, right? And the reason is that we need to merge these two t. Okay, so you see, maybe let's do it carefully. Let's do it, change this into this. So this is just nothing, right? I just write it. So I preserve the final terms and check this term into a half. And then when I do this, I just replace this k. Okay, replace this k as 2k. So it's like 2n minus 2k factorial divided by 2 to the 2n 2k, k factorial n minus 2k factorial. Let's say n minus k factorial. And this is 2x n 2k tn minus 2k. And the reason is that, okay, so I just rearrange it, the order of summation, okay, to be this, okay. So now Tn is independent of k. So you see, in general, this is n plus k, right? But I change it to there's no independent of k. Okay, so let's combine it, then you will see this is the Legendre polynomial. K from 0 to n square root, the floor function n divided by 2, and this is 2n minus 2k factorial, 2n k factorial n minus k factorial, n minus 2k factorial, x 2n minus 2k. Okay, and this is our starting point. We just replace k by r. Okay, and we can get the Rodrigues formula. Okay, so that's the proof, and I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.